everyone, and welcome to topic 2 in geometry. Today we are going to talk about the relationships that are created when we have lines cut by a transversal, and specifically what happens when they are parallel, what kind of angles are formed. So the idea of a transversal, we see this vocab word here, it is a line that intersects two or more coplanar lines on different points. And again, coplanar just means they're on the same plane, or like think about you drew them on the same piece of paper. So notice we have these two lines here. The transversal would be this line that is intersecting both of those lines. And when we have that transversal cutting through those lines, we have different angle relationships being formed. For instance, we have corresponding angles. Corresponding angles are angles that are on the same side of the transversal, but one is on the interior, one is on the exterior, but they're kind of in that same position. So for instance, angle A and angle E in our diagram are corresponding. Angle D and angle H, angle B and angle G, angle C and angle F. Okay, so those corresponding ones, they're going to be again in that same location. Same side interior angles are on the same side of the transversal and in between our two lines. So for instance, C and E or D and G would be considered same side interior. And we also have same side exterior, A and F, B and H. Now, like we have same side, we also have alternate sides. So we have alternate interior angles like C and G. So that'd be N, D, and E. Or we have alternate exterior like A and H or B and F. Now, we can start naming some of these relationships as well. So, for instance, our corresponding angles, we notice right now we have a transversal right here with line L, and then we have these two other lines being created here. So, when we look at the corresponding, we want ones that are on the same spot, kind of on that transversal, one on the interior, one on the exterior. These I like to think are like to the left, the upper left of our transversal. So we would say angle 1 and angle 5. Or we have, for instance, 4 and 8. And then we also have 2 and 6. Or we have 3 and 7. Now our same side interior, again, are going to be our angles that are both on the interior and on the same side of that transversal. So for instance, we have same side interior would be angle 2 and angle 5. But we also have on the other side angle 3 and angle 8. Now, can you predict the alternate interior angles then? We should have had angles 2 and 8, and then the other set would be angles 3 and 5. Now, just like we had same side interior, we can also talk about the same side exterior angles. So again, here's our transversal. Exterior same side would be angles 1 and 6. And then we would also have angles 4 and 7. Those are our same side. What about the alternate exterior? If you're saying angle 1 and angle 7. And then finally angle 4 and angle 6. Now, don't forget, whether we have a transversal or not, when we have these intersecting, with that transversal, we have these intersecting lines. So we are creating each time vertical angles. So we would say, for instance, like over here, we had angle 1 and angle 3 would be vertical. We have 2 and 4. And then we also have over here angle 5 and angle 7, as well as angle 6 and angle 8. Linear pairs as well exist. Now we have a whole lot. I'm not going to probably write all these down, but for instance, 2 and 3 would be an example of a linear pair, but also 3 and 4. Those are those angles that are supplementary and adjacent. So we notice we have a lot of those relationships running around in each set, 8 total, as a matter of fact, to be able to get these linear pairs. So again, like angle 5 and angle 8 also work. Now, our parallel lines cause something special to happen. Now, parallel lines are lines that do not intersect. They could go on forever and ever and ever, and they do not intersect. So notice these two lines here, they would go on for infinity, but would never intersect. Now, how do we know they are parallel? Notice these special tick marks. You're going to use arrows as your tick marks to show that these are going to be parallel. So you see this arrow like here and here, those are going to show us, or we have the double arrow to show us that these two are parallel. So you use the arrows as your tick marks as opposed to our other ones. So this is telling us, without them writing in words, we know that these lines would be parallel because of those arrows. Now, when parallel lines happen, they cause some of those relationships from the other page to have special development towards each other. So, for instance, on this last page, like these did not necessarily look parallel. So, we can't say that these are true. But if we know they're parallel, we know these relationships will for sure happen. Okay. So, for instance, our same side interior angles, this actually also goes for the exterior as well. But what's going to happen is the same side interior or exterior are going to be supplementary. So they're going to add up to equal 180. Alternate interior or alternate exterior, notice those are both listed there, they're going to be congruent to each other. So they're going to have equal measure. So will our corresponding angles. So angle 1 and angle 2, those are corresponding. They will also be congruent to each other. Okay, so same side, either exterior or interior, are supplementary, and then the alternate interior, exterior, or corresponding are congruent. Okay, so assuming that these are parallel lines, we want to name the relationship, and then if they are either congruent or supplementary. So if we look at number 1, x and y compared to each other, they are corresponding. Okay, and we know from up above, if these lines are parallel, our corresponding angles will be congruent. In the next one, going back to what we talked about in the last topic, actually, we have two vertical angles. Now, regardless of if the lines are parallel or not, we know vertical angles are always congruent. Okay, we knew about that from the last unit, even without parallel lines, but vertical angles, they are congruent. Next one, same side interior angles. So I'm going to abbreviate same side interior. Those are supplementary to each other. They're going to add up to equal 180. Next on the list, these are alternate exterior angles. And again, the alternate exteriors are congruent or equal in measure. Try this last one on your own. For letter E, what are the angles? What are the relationship then? All right, last but not least, this last section is talking to us about, okay, what is happening if we have multiple lines intersecting each other? And each time it wants us to do two things. Number 1, it wants us to name the transversal. And then again, we want to identify the special angle name for each pair. So for the first one, we are looking at angles 3 and 10. So here's angle 3, here's angle 10. This time our transversal is going to be, again, the line that's kind of creating them with our two other lines. The transversal this time is going to be line P. And in this case, if we look at this and compare it to these other two lines, we would say that angle 3 and angle 10 are same side interior angles. And now we don't officially know if these lines are parallel or anything, but we would know that they're same side interior regardless. All right, next one is asking us about angles 2 and 12. Now again, our transversal is going to be line P. And this time our transversal has angle 2 and angle 12. Those are going to be our alternate exterior angles because they're on opposite sides of the transversal and they're on the outside of what we would call our two lines of that we have here going through. Next, we have angles 8 and 14. We have angle 14 here, angle 8 here. This time we are switching up with our transversal. This time our line Q is going to be our transversal. And this is an example of alternate interior angles because these are on opposite sides of our transversal, but in between the two potentially parallel lines. Now, angle 9 and angle 16 are kind of interesting because if we look at angle 9 and then we look at angle 16, notice there's not a direct relationship. Our transversal is line M, but these are not on both on the interior or the exterior, and they're not corresponding. They're not in the same spot. So there's no direct relationship. Okay. But what we could say is that angle 9 and angle 11 are going to be congruent because they are vertical. And then angle 11 and angle 6 are supplementary. So, or not necessarily, but they're same side interior. So we know that there's potentially some relationship there. But there's no direct relationship between these two otherwise because of that. So just be careful there. All right, last two I'm going to have you try on your own. First, you will be looking at angles 5 and 1. So what is your transversal? And what kind of relationships would they be? And then for the second one, you're looking at angle 1 again, but this time angle 12. Thanks everyone for watching. We will definitely work more with these values in class.